Hello students, welcome to your third Java lesson. I know you're so excited because we're going to talk about some expressions and assignment statements. Hey look, we're into a new section. Congratulations. Alright, we're going to mostly talk about in this lesson identifiers, variables, and assignment statements. So you'll probably think of it as like, oh, does this mean there's math? Well, yes, but we're not going to do the math. We're going to make the computer do it for us. We just have to think about how to make it. So let's get some started here. Alright, recall in math what a variable is. Math, that variable represents an unknown value. In programming, a variable roughly means the same thing, time in theory, but instead of representing some unknown value, it's simply just representing a data value that we may or may not know. Now, identifiers is another thing we're going to throw around here. In math, we just gave a variable name, x, y, n, whatever letter of the alphabet, alpha, beta, it doesn't matter. Right? In programming, we do a similar process here, but we kind of follow a set of rules. So we can't just say x. What is x? Well, in Java, those rules are the following. Right? You're not going to start your variable with a digit. You're not going to say 1. Or you're not going to say like 1a. Those are not valid variable names. Right? The characters, all the characters in the name, I should say, must either be letters, digits, or the underscore character. Now, as you can't use something like exclamation point, or period, or dash and something, because those are considered to be poor choices. So if you want to separate words, use underscore, otherwise letters and digits. All right, so here's a quick examples. I got x, x1, ABC, 1, 2, 3, a underscore b. Now, if I look at those, right, while they are indeed variables that are following the rules that have been laid out, they're considered to be poor choices for identifiers because they're not at all descriptive of their use. Like if I don't care what they're for, like I'm just like adding two numbers, yeah, I can just use like a and b, x and y, n and m. Yeah, that's fine. But when I'm trying to write a program, more often than not, I want my variables to have some kind of meaning. So let's jump into that, starting first with case sensitivity. Right? Java is case sensitive, right? Which means it's going to treat upper and lowercase letters as different characters. So a capital A is different from a lowercase a. This means the words rate, and rate would all be considered different values. You notice one's all lowercase, one's all uppercase, and the one only the first letter is uppercase. However, it's generally considered to be a bad idea to use such variation as it can become a little confusing which rate you're talking about. If you notice, they're pretty much all the same thing, it's just different capitalization. So we generally avoid that. But if we want something similar, we'll start sticking like numbers after them. Additionally, convention calls for the first word to be lowercase. So if you have multiple words, your first word's all lowercase. And each successive word is capitalized. So the first letter is capitalized. And this is what's known as camel casing. All right? Just think about how a camel is. You got humps in the middle. It's the same idea here. All right? So top speed, the S is the hump of the camel. Bank rate 1. The R is the hump of the camel. Time of arrival. Oh, that's a 2-hump camel. You got of and arrival. That's just the rules that we generally follow. Now, this slide I have to talk about more than anything else because this can cause some grief for students if you don't understand what keywords are. Now, even though we can call our variables just about any identifier we want, there are two things that you should do and be aware of. The first thing is try to identify your variables with a name that matches what they are being used for. All right, here's a quick example. We're going to use count. Right, and that's going to be used to keep track of count of numbers. That makes sense. Count's counting. Right? A keyword or reserved words. Right? These are words that are used by Java that already have predefined meaning. Therefore, you can't use them. Some quick examples. Things like system, print line. Those are things that Java already has definitions for. Public, class. Those all have definitions within Java. If I made something like that's just X, X is not something necessarily defined by Java. So I could potentially use X. I could also use number, or in the previous example here on this slide, count. Declaring a variable. Now, declaring a variable must be done before it's used. So I can't just say x, because the program's going to look at me and say, well, what is x? So here's some two quick examples. Int amount of cereal, double 1 weight, comma, total weight. We're going to use int for whole numbers, and we're going to use double for decimal or floating point numbers. Now there are other things that we can get into, but just for starting off here, int and double are two friends. You can declare more than one variable at a time using commas to separate the names. So if I look back at my example up here, all right, int amount of cereal, it's one variable. Now I could, if I look at the next one, I got double 1 weight total, and that should be a lowercase d. I'll have to fix that in the annotations. All right, double 1 weight total. Now with that, that means that I could put double 1 weight, semicolon, double total weight, semicolon. However, it's nice to kind of clean it up a little bit and put it all as one line, because then I don't have to write double twice. So that's the reason why we can do that. Now, primitive types. Now remember, I did say, there's just not just int, double, there's some other types. So there's a whole list of them, but here's some basic types of data that you're going to encounter, and these are the ones you're probably going to encounter the most. All right, Boolean. We will be using Booleans in this course. All you need to know that in Java, they mean true or false. In some other languages, they mean like 0, 1, but here they just mean true or false. And they only use 1 byte of memory. A char is a single Unicode character. And remember, even the spacebar is technically a character. Any letter, any number, a good way I always tell students, any character on your keyboard is a char. All right, that takes 2 bytes. An int, which is short for integer, takes 4 bytes. Right. Float, floating point number. Right. Now with floats, what those are is that they are decimals. But they tend not to be as big, because if you notice, they only have 4 bytes available. Whereas a long is also an integer, but we generally don't use long that often unless we're going to be dealing, with big numbers. All right. Then those are 8 bytes. Then we have double. Double is a floating point number. Right? And that's also 8 bytes. So again, the two most common ones that we're going to use are going to be int and double. You will see char and boolean. Occasionally you might see float and long. You might even see short, which is a very unique one. It's another type of integer, but generally we're not going to get too much into short. Assignment statements. So if you recall, in the 2 slides ago, we talked about declaring a variable. Like I had double 1 weight, comma, total weight. But I didn't actually give them a value. If I ask you, what is the value of double 1 weight? And you just said, well, I don't know. You'd be right. There is not a value assigned to it. All right. So in order to give that variable a value, we have to use what's known as an assignment statement. All right. In Java, we use the equal sign as our assignment operator. So here's some quick examples. Total weight is equal to first weight plus second weight. Temperature equals 90.6. Count equals count plus 2. Now notice these are just assignment statements. There's nothing that says that these have been declared. You have to declare a variable before you can assign it. All right. So let's talk about doing that all as one thing. Because you have to do declaring and then you have to do assignment, but you can actually initialize. So if we just write int number, right, the value has been declared, but it's uninitialized, meaning it has no value. Now when I say no value, does not mean that it's 0. Please, please, please don't assume that because something doesn't have a value, it's 0. If you say nothing, that's actually closer than saying it's 0. Now, generally speaking, we want to give our variable a starting value. Note there are exceptions, which we will look at. But sometimes we want to give that variable just something to start off with. So here's some quick examples. Int count is equal to 1. Double speed is equal to 65.5. Char grade equals A. Int initial count equals 50, comma, final count. Now I want to point out this last one here, real quick here. Int initial count equals 50, comma, final count. If you look at it, you'll see that initial count has a starting value. But would you argue that final count has a starting value? If you said final count does not have a starting value, then you are correct. All right, let's look at a couple more assignment statements. Here's a couple other things that we could be using in the future. All right, these are kind of like almost like some shortcuts. All right, so count plus equals 2. All right, that is the equivalent to count equals count plus 2. So you're just adding the variable to the value. Total minus equals discount. The same thing as total equals total minus discount. Subtracting the value from the variable. And then change modulus equals 100. Right? That percent sign does not mean percent 100. That means modulus, all right, which is setting the value of the variable equal to the remainder of the variable divided by the value. All right, initializing a variable in a declaration. One important thing that we can do to save us time of code is declare and initialize the variable all in one line. So this is going back to the stuff I've kind of already mentioned, but let's look at it. So instead of writing int number and then number equals 2, how many lines of code is that? 1, 2. Let's condense that down into one line of code. Int number equals 2. Now, I don't know what you do, but if I can save myself some time and write the code a lot neater, I'm going to do that. So I'm just going to put int number equals 2. It's the same thing. If you notice, int number equals 2, and int number equals 2. They're the exact same code, but it's convention to follow, and it's going to look a lot neater. Again, and also, here I have 2 lines, here I have 1 line. All right, we've made it to the self-test questions. So here we go, folks. Number 1, which of the following can be used as a variable name in Java? Rate 1, first place, myprogram.java, long, time limit, number of zeros. When you're doing that, make sure you are looking at the ones that are also following our conventions for camel casing. Number 2, can a Java program have 2 different variables named number and number? Number 3, show the code. Right? I want you to actually list out the code. You don't just, so I want to see like int, whatever. Right? Give the declaration for 2 variables, feet and inches. Both variables are type int, and both are to be initialized to 0 in the declaration. Number 4, give the declaration for 2 variables called count and distance. Count is of type int, and distance is of type double, and is initialized to a value of 1.5. All right, and we have another one here. Question 5. What is the output produced by the following lines of code? Char A, comma B. A equals B, system.out.println A. B equals C, system.out.println B. A equals B, system.out.println A. All right, and that wraps up this lesson, folks. Until next time.